All right, well, good morning. How's everyone doing today? Good? Good? Hopefully warm? Warm? I know, we're down in Georgia. Why is it 30 degrees outside? As for me this morning, I'm feeling groovy. My name's Adam Kaplan, and I'm going to be your instructor for today for Containers 101. I'm a software engineer at Red Hat. I have been contributing to Kubernetes for almost a decade now, or I should say working with Kubernetes. I am currently a maintainer of the CNCF Shipwright project. I've also contributed to Tekton, Kube itself, and a bunch of open source projects. So today we've got 5 topics on our agenda, and our time is short, so I'm going to try and be pretty quick. So the first item on the agenda is what is a container image, since this is Containers 101, how to build a container image, how to publish your images, how to then build those images on continuous integration or CI systems, and then finally, ways that you can deploy your images to production. So before I begin, I want to give a big thank you to Simon and Danielle and the rest of the program committee for bringing you together this event, and also everyone else who is part of the program committees for KubeCon and Cloud Native Con. I previously served on 2 different program committees for CDCon. It is an enormous amount of work. So before we begin and start everything today, please give them a big round of applause for all the work that they've done. It's all volunteer. They don't get paid. Every submission that came in, they analyzed, looked at with love and care. So from my heart to yours, thank you. So I found myself when I was in school, I was a hands-on learner. So rather than just lecture you on how to build containers, I'm going to show you with actual code. And so here's my GitHub, where it's a monorepo for an application called QuizApp, which, you can maybe guess from its title, is designed to run quizzes. So I thought, why not get you all in the school spirit with a pop quiz at 9:15 a.m. on a Monday morning? So hopefully you all are well caffeinated or awake, so we can begin the quiz. So question number 1, starting the topic for our first topic, I should say, is what is a container image? And so I want you to raise your hand and say I for each response. So raise your hand, say I if you think it is a lightweight virtual machine. Go ahead, you can speak up. So we want to hear on the recording. Raise your hand if you think and say I if you think it is B, a file system with some metadata. Raise your hand and say I if you think it is C, a picture of a metal box. I hope if your answer is C, you've got a lot to learn today. You all said B, and you are correct. You are correct. I'm actually very impressed. So many folks, when you first start learning about containers, you're usually using Podman or Docker, and you're given this sort of lightweight virtual machine analogy. And that works pretty well for running software, but it's not the complete picture. So the actual definition is set by the Open Container Initiative through the OCI image specification. And the definition is remarkably broad. According to the OCI spec, a container image is simply a set of file system layers and some metadata attached to it, usually in JSON format. And because of that, we can do some really powerful things besides just ship software. So for example, today, you can use OCI images or artifacts. We usually use that term if the container doesn't have any running software to package and distribute things such as Helm charts, SIG-store signatures, and in-toto attestations. Actually, if you're, I assume you're all going to be here for the full conference. Tomorrow, there's an excellent session from GE Healthcare and Microsoft about how they are using OCI to create an infrastructure as code platform as a service within GE Healthcare. Looks very interesting. I want to try and check it out. So that covers the fundamentals for what a container image is. But let's try and now build one, which then brings me to question 2 of my quiz. True or false? A Docker file is required to build a container image. Raise your hand and say I if you think that is true. Raise your hand, say aye if you think that is false. You're very good. You're very good, because that is indeed the right answer. You do not need a Docker file to build a container image. There are many tools there today which do not require a Docker file to let you build an image, and today I'm going to show you 2 of them. Oops. In my repo, I have a front end and a back end. The front end I have built with JavaScript, so I'm going to be using Cloud Native Buildpacks to build it. And for the back end, I'm going to be using the Code project. Both of these are in the CNCF, and you can learn more about them. I think we've got a few sessions in KubeCon about Buildpacks today, and I think they also have a lightning talk in the project pavilion today, this afternoon. So with Cloud Native Buildpacks, the way you build your image, and I'll show you a bit of my code, is you invoke the pack build command, which is similar syntax to Docker build or Podman build. Like Docker build or Podman build, you need to provide it the name of the image, which is also known as an image reference. But unlike Docker, you also have to provide it what's known as a builder image. And so there's a wide ecosystem within Cloud Native Buildpacks of these builders. And for this demo, I'm going to be using the Paketo Buildpacks Jammy base image. So when you start the build with Buildpacks, it invokes its lifecycle. And the way the lifecycle works is that it analyzes your code and detects which software packages you are trying to use, and then it automatically pulls in those software dependencies and SDKs to build the image. Now, this process can take a little while, so while this is going on, I'm going to go ahead and start the backend with Co. And Co is similar in that it is a build syntax. However, the mechanics of it is a little more, a little different, I'd say. Co is, unlike Buildpacks, it can't build any software. It's optimized and designed specifically for Go. The other thing about building with Co, it's got opinions even on how container images are named, and can build more than one image in a single invocation. So what you have to do with Co is provide it this Docker repo environment variable to give the sort of base of the image that you're going to then build, and then tell it which Go packages you want to build, and then it takes care of the rest. It uses the Go SDK that's on your machine to first compile the binary, and then once the binary is compiled, it then packages it into the container image using best practices from the community. And so since both Go and Co have pretty strong caching mechanisms built in, and I've already built this locally on my machine, the build runs very quickly. So I'm going to pop back over to that Cloud Native Buildpacks build, and you can see that the build has finished. I can maybe jump forward to see what the logs look like. And similarly, Buildpacks has additional features baked in using best practices from the community. That good? Everyone understand it? Great. So now we have the container image built, and it's on my machine. But we need a way to get this container image to production, which brings me to the next question on my quiz. And given the way that you've been answering so far, I'm pretty sure you're going to knock this one out of the park. Where can you find container images? Raise your hand, say aye if you think it is A, on a registry. Raise your hand if you think it is B, on ChatGPT with the right prompt. We got a few ChatGPT users here. Raise your hand, say aye if you think it is C, on an image search website. Y'all doing great this morning. It is indeed on a container registry. That said, I'm pretty sure with the right prompt and the right LLM, you might get it to build a container image for you. So today, what I want to show you is a container registry called Harbor. Harbor is a CNCF graduated project that provides a production-grade container registry. One of the things that's nice about Harbor is that it has a user interface that makes it easy for cluster administrators or platform engineers to administer. when you are setting up Harbor and you want to publish your images to it, you have to create what are known as projects. In other container registries, this might be known as a repository or an organization. The terminology isn't quite the same across them. Within Harbor, you can specify things like robot accounts. So for example, I have a robot account here, so I can do CI. You can also integrate Harbor with OIDC or other identity providers so that you are set to go in an enterprise environment. So now we have my images. I have a registry that I can deploy it to. However, I don't think you should trust the images that were built here because, after all, I'm on conference Wi-Fi, and especially if I was at something like a hacking convention, that would not end well. Most enterprises require you to build your images on a trusted system, also known as a continuous integration or CI system. And for companies that are looking to cloud native and using Kubernetes, Kubernetes could be a great fit for this. There's a lot of security controls baked in. You got isolation through containers. And the default path, anyway, is you run your applications with containers. Which means, in theory, you could use Kubernetes to do your CI. But you need answer a critical question, which is the next one on my quiz. Let's see if I stump you on this one. True or false? Containers cannot be built within a containerized environment. So raise your hand, say aye if you think it is true that you can't build containers in a containerized environment. Raise your hand, say aye if you think it is false. Aye. Good. Raise your hand, say aye if you think just, I don't know. I'm confused. It's okay. It's okay. We're here to learn. So the answer, y'all are knocking this out of the park. It is indeed false. You can build containers within a containerized environment, which means you can build on Kubernetes. So the way I'm going to do it this morning is with two tools that work together. Shipwright and Tekton, and I'm a little biased. I'm one of the maintainers of Shipwright, and I also contributed heavily to Tekton. So Shipwright is basically an API and framework for building containers on Kubernetes. And the way it works is that you define three things in your build. First, you give it the source, which for this example, I'm using source from Git to build my front end. You then tell it which tool to build, which we call build strategies, and the community maintains a set of sample strategies that you can use right out of the box. And the third is that you need to publish it to a container registry, which in this case, I'm going to be publishing it to Harbor that is running on my cluster. In order for me to do this, I have to provide it some credentials to publish to the registry, which you can see here. Those were actually from that robot account that I showed you earlier. So I'm going to go ahead and first create the build by adding it to my cluster. And I'm going to do this using the kubectl command line, which is the standard interface for interacting with Kubernetes itself. The Shipwright build, if you are aware of how Kubernetes works and extensions work, the build is actually a custom resource definition, which lets you extend the APIs for Kubernetes. So I've created now this build object. And I'm going to use the command line from the Shipwright community known as ship to run it. And the command's very simple. You say ship build run. You give it the name of the build that you want executed, the namespace if necessary, and by passing the -f flag, I can follow the logs. And you can see this is actually the logs from the pod that's running on my cluster. It clones the repo, and then you can see it's starting the Cloud Native Buildpack build like you saw earlier. I'm going to do the same for the back end. I'll create the build object, and for the back end, I'm using the co-build strategy from the community. And then similarly, I'm going to start the build and follow the logs. And while that's running, you can actually watch the status of the build as it's going. Using the same command line, you can see both the front end and back end are running. These eventually complete. I have some successful builds that ran a few minutes ago. And with that, I now have a build that is published to a registry from an environment that I can trust. So now we're ready for topic number 5, getting this thing deployed to production. And if you're not familiar with how Kubernetes works, there's a lot that goes into deploying things to production than just the container image. You need to create a whole bunch of objects to make it work, such as the deployment, service to bring traffic to the containers that are running. You also need to provide a way for traffic to get in to the cluster. And in this example, I am actually using the Gateway API, which is a new extension to Kubernetes, kind of reimagines how ingress works into clusters, which I personally find to be very intuitive. There's going to be a lot of sessions, I believe, at KubeCon this year about Gateway and the progress that they've made over the past year. So this, again, brings me to question number 5 of the quiz. Which command can deploy a container image to Kubernetes? kubectl apply-f, raise your hand, say aye if you think that's true. B, kubectl apply-k, if you think that's true, raise your hand, say aye. C, helm install. D, ArgoCD app sync. Or E, all of the above. Raise your hand, say aye if you think it's all of the above. You guys are rocking it today, really rocking it. It is E, it's all of the above. As a matter of fact, these are not all mutually exclusive. And today I'm going to show you that with ArgoCD. So ArgoCD is a part of the Argo project, which is, I believe, a graduated CNCF project that lets you synchronize the deployment data from Git into your cluster. There's another project called Flux that is in the CNCF that provides similar capabilities. We got a lot of might have a few Flux folks here. I would be remiss if I did not mention them as well. So the way ArgoCD works is that you first, as I mentioned before, define your application definitions in Git. And Argo and Flux is kind of the same way, can handle all sorts of different topologies. It can handle applications that are used just plain kubectl manifests, customize templates, Helm charts, and so forth. So I've actually got a grab bag of these on my GitOps deployment repo. The quiz app application, which is running the quiz, is using a Helm chart. This lets me template things out like the image and the replica count that I'm using for the application, so that like when I'm using it for my own development purposes, I can change some of these settings. I've done a few other things as well. For example, the Shipwright deployment that I have, I'm using Customize, where I'm taking the release from upstream, and I've patched it with Cert Manager so that it works with Cert Manager to handle some of the admission webhooks that are baked into it. So once I have that information in Git, I then tell ArgoCD to synchronize the data through the application, custom resource, and Argo also provides a user interface for this. And so you can see I have the repository here that it's pointing to. I tell it which path it needs to be at, and it's able to interpret that this directory is a Helm chart and is able to synchronize the data to my cluster. And you can see the state in the user interface. I've actually done this for everything on my cluster. So you can see here I've got the gateway, I've got Shipwright, that Harbor registry. I even have ArgoCD itself being managed by an ArgoCD application, which is kind of cool. So this practice is known as GitOps, and we actually have a lot of talks related to GitOps happening today at the co-located events. So ArgoCon is happening right now, runs all day. There are several projects there related to, talks there I should say, related to ArgoCD that are worth checking out, as well as their related projects, Argo rollouts, Argo workflows. And this afternoon is FluxCon, so you will be able to attend that if you want to learn more and get hands-on with GitOps. So I guess in past 15 minutes plus, we've gone through a lot. And so I want to zoom out a bit. We've covered a lot of different tools that you could use to build and deploy your applications. And right now, you're probably feeling like a rock or an island stuck in the middle of a bunch of troubled cloud-native waters. I forgot to mention this earlier, but the talk title was inspired by the work of Paul Simon, and so those 2 slides were references to his work. If you're not familiar with Paul Simon, I recommend looking up his music on your favorite streaming service or music provider of choice. So I'd like to ease your mind a bit and help you decide which tools are right for you. So first, when it comes to building images, the choices are really between those that use container files, Docker files, and those that aren't. Container file and Docker file are really the same thing. It's the same syntax. It doesn't matter really what file you use, it's the syntax that matters. If you're used to using Podman or Docker, there are CLI variants that are optimized for just building the container images, particularly within a container. So if you're using Podman, Builda is literally the same code. If you're using Docker, Moby Build Kit is more or less the same. These give you maximum flexibility. You can add any content, which is great, but can also open you up to security risks. With opinionated builders like Cloud Native Buildpacks and Co., you do have paths to having no-code quick starts. You can get started right away. Your development teams don't need to learn how a Docker file works. You're also getting the best practices from the community, such as adding software bills of materials to your container images. That said, these tools can be a little limited in terms of things that you can add or extend, and the configuration of that can be complicated. When it comes to publishing images, I showed you Harbor. There are 2 other open source alternatives that I want to mention, which is the CNCF distribution project, which is the reference implementation for the OCI distribution spec, and Project Quay. Each has lots of different features that are baked in, but the 2 that I kind of want to call out here this morning are whether or not those registries support OCI version 1.1 and which artifact types support. So OCI 1.1 has a feature called the Refers API that lets you set relationships between the container images on the registry. This is really powerful and is used a lot in the software supply chain space that I work in these days. In addition, not all container registries support arbitrary OCI artifact types. Particularly for hosted container registries, they might not let you store things such as Helm charts. For CI systems, and this is probably one of the biggest challenges for any organization in terms of what you can choose, there are lots of options, both open source and proprietary. Probably my best advice is to first ask what you're using today. In terms of what's open source, I showed you Tekton, but there's also Argo workflows, which is part of the CNCF, as well as Spinnaker and Jenkins, which really started it all. Which one to use? If your organization is using one of these, I would probably recommend starting with those because it's just going to be a little bit easier for you to adopt. Otherwise, if you're doing a greenfield project or you're just looking to adopt a CI solution, 2 things that I recommend you look out for is first, how are the pipelines isolated and how the logs and job records are retained. So Argo workflows and Tekton are similar in that they are both using Kubernetes to do the pipeline isolation using containers, and also is how the job records and logs are stored. And while for the first one, the isolation and security controls that you can get with Kubernetes are excellent, the downside is that the logs and job records are not meant to be permanent. As a matter of fact, if you let that data just sit on your cluster, you actually risk cluster death because there's too much data on it. Tekton has an add-on called Results, which lets you take those jobs and logs off of the cluster and put them in more permanent storage. I'm a little biased. I was one of the maintainers of it. Finally, for deployment, I showed you several options. You have kube control, which is kind of the standard tool. There's no extra YAML that you need to learn. However, it's very difficult to template. This is kind of like a spectrum of tools. Kustomize is next. It gives you support for basic templating. It's flexible, but sometimes can be a little too flexible, and your deployment directories can look like this. Helm is, on the other hand, designed for sharing and templating. It's got a sophisticated templating engine, which is positive and negative. In addition, the values YAML, at least in Helm 3, is kind of like a soft API. you risk breaking changes. The last one I want to mention is KubeBuilder and its related project operator framework. Both of these are part of the CNCF. And unlike Helm customizing kubectl, instead of using YAML, you're actually writing code. And you're extending Kubernetes using custom resources. This is great if you've got a very sophisticated application with complicated install or upgrade logic. But unfortunately, this means that you have to write code, which you need to containerize, and you need to deploy, which means you are back where you started. So before we go, and I've got maybe less than 5 minutes left, I want to give you one final question. We've seen a lot of tools today. We had 3 registries, 4 build tools, 4 CI tools, 4 templating engines, 2 ways to do GitOps. So I'm going to leave you, whoops, geez. Final question on the quiz, and maybe I gave away the punchline. How many ways can you build and deploy containers? 17? Raise your hand, say aye. Raise your hand, say aye if you think it is B50. Raise your hand and say aye if you think it's 67. I see some people cringing, rightfully so. How many think it is E, more than 192? A lot of ayes here, and yes, I did give away the punchline. It is indeed, if you do the multiplication, more than 350 ways to build and deploy containers. All the stuff that you saw here is referenced in the slides on Sched. I think I'm almost out of time, maybe 1 or 2 minutes for questions. If you enjoy this talk, please rate it on Sched. You could use the QR code here. Otherwise, thank you, and I hope you all enjoy the rest of Cloud Native University.